Just as we use the definition of absolute value to enable us to solve equations involving absolute value, today we will apply the same logic to solving inequalities involving absolute value. I want you to recall the definition of the absolute value of a number. The absolute value of a number A, written A with lines on either side of it like that, is the distance between A and 0 on the number line. For example, the absolute value of 3 is the distance between 3 and 0 on the number line. You'll notice that there are 3 units in between 3 and 0. And also the absolute value of minus 3 is 3. The distance between 3 and 0 or minus 3 and 0 on the number line, either way, the distance is 3 units. The absolute value of 3 or minus 3 is 3. And the absolute value of 0 is 0. The distance between 0 and 0, of course, is 0. Okay, and if you'll recall, when we wanted to solve an absolute value equation, for example, something like the absolute value of x is equal to 2, okay, we were trying to find all values of x so that the distance between x and 0 would be 2 units. That is, x should be 2 units away from 0. Now, of course, if you look at the number line here, if x is going to be 2 units away from 0, it could be either 2 units to the right or 2 units to the left. So there were 2 possible answers. X could be either 2 or x could be minus 2. And we were able to solve more complicated absolute value equations using the same logic. Okay, the important thing here is the distance between x and 0 is 2. That means x is 2 units away from 0, but it can be on either side, so you get the 2 answers. Okay, now let's move into absolute value inequalities. Okay, suppose we want to solve the inequality, the absolute value of x is less than 4. It's an absolute value inequality. There's an inequality involving the absolute value. Okay, we're trying to solve. We want to find all values of x for which we could substitute into this inequality and have it come out a true statement. The absolute value of x is less than 4. That means the distance between x and 0 is less than 4. Or x must be less than 4 units away from 0. Let's look at the number line here. X is to be less than 4 units away from 0. Okay, well, certainly around 0 on either side here, we're okay. We're less than 4 units away from 0. In fact, we can go up to 4 or minus 4. In other words, anything from here to here. Any values of x from minus 4 to 4, but not actually including the minus 4 and 4, because then you would be 4 units away, and we only want to be less than 4 units away. Okay? We want the absolute value of x to be less than 4. The distance between x and 0 to be less than 4. X should be less than 4 units away from 0. We are allowed leeway of 4 units on either side, actually less than 4, up to 4 units on either side, to the right or to the left. Okay, so we see that a way of writing the solution set in this case would be minus 4 is less than x is less than 4. In other words, x minus 4 is less than x means x is greater than minus 4 and x is less than 4. X is to be greater than minus 4 and less than 4. That is someplace in this region, as long as you're in here. Okay? As long as you're between minus 4 and 4, the absolute value of x will be less than 4. For example, if you take a number like 3, the absolute value of 3 is 3, that's less than 4. The absolute value of minus 3 is also 3, that's less than 4. Okay? Minus 5 is no good. The absolute value of minus 5 is 5. That's not less than 4. So we are restricted on either side. Okay, and if we wanted to graph this, we could put on the number line. Here is 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. Since it's all values between minus 4 and 4, but not including the endpoints, okay, we could put a little circle in here to indicate that 4 is excluded. Little circle here to indicate that minus 4 is excluded. We only want those values between minus 4 and 4. And there is the set of all possible values for x indicated on the number line. Everything greater than minus 4 up to, but not including plus 4. If this had an equal sign, this would have an equal sign, and so would this, and we would indicate that on the picture by filling in these circles to indicate that the endpoints would also be included. Okay, let's try one with the endpoints. The absolute value of x less than or equal to 3. We want all those values of x so that the absolute value of x is less than or equal to 3. That is, the distance between x and 0 should be less than or equal to 3. Now, where are those numbers? Okay. Well, certainly a number like -3 is okay because the absolute value of -3 is 3, and that's less than or equal to 3 because the equality holds. Remember, this is less than or equal. If you substitute in -3, you do get a true statement. The absolute value of -3, which is 3, is less than or equal to 3. Okay, so -3 is acceptable. -2 also, -1, and so on, because the absolute value of these numbers would be 2, 1. The distance is going to be less than 3. Up to and including 3, we have all the values that are okay. The distance between x and 0 should be less than or equal to 3 units. Okay, so we can write that as x is to be greater than or equal to -3 and less than or equal to 3. It is between -3 and 3. We can write it very nicely like this without the absolute value. And in general, we have the following rule. If a is a positive number, the absolute value of z, I'm using something other than x because sometimes the expression in the absolute value sign is an expression involving x rather than just x by itself. The absolute value of z is less than a. Okay, this absolute value inequality is equivalent to, okay, this symbol means is equivalent to, or can be replaced by, this inequality without absolute values. Okay, just like we did over here. The absolute value of x was less than 4 was replaced. This is equivalent to x being between -4 and +4. The absolute value of z is less than a can be replaced by z being between -a and a. That is, the distance between z and 0 should be less than a. Z has to be within a units of 0, but it can be on either side. -a less than z less than a. And also, if this was an absolute value inequality involving the less than or equal to symbol rather than just the strict less than symbol, we would replace it by the same type, except all the symbols would be less than or equal. And we've seen examples of both of these on this board here. This is the less than, this is the less than or equal. And notice how it changes when you're indicating the graph on the number line. If it's less than, you have the open circle. Less than or equal, the endpoint is included. Okay, you fill in the circle. Okay, now this business about a being a positive number is important. Okay, let's see what happens if a were a negative number. For example, the absolute value of x is less than -4. We want to solve this inequality. The absolute value of x is to be less than -4. We see in this case there can't be any possible solution to the problem. Now, you do not proceed like this. This is only if a is a positive number. Okay, if a were a negative number, okay, or if a were 0 here, the absolute value of x less than -4 cannot have a solution. We would want the absolute value of the number x, that is the distance between x and 0, to be less than -4. But we all know the absolute value of a number is either 0 or positive. It can never be negative. So there is no way that the absolute value, which is a distance, the distance between x and 0, can be less than -4. Okay? The best we could hope for would be, the smallest you could get would be 0, or it would be positive. It would never be less than a negative number. So this has no solution. Okay, so we're talking now about less than inequalities. Absolute value less than inequalities. Okay? Less than or equal. And this is based on a positive right-hand side here, and if it's a negative, there is no solution. Let's try some more complicated absolute value inequalities. The absolute value of 2x minus 5 is less than or equal to 5. Okay, this 2x minus 5 is just a number. Okay, the distance between 2x minus 5 and 0 should be less than or equal to 5. That is 2x minus 5 has to be someplace between minus 5 and plus 5. Okay, if you want to use the rule that I gave you here, z in this case is the 2x minus 5. A is 5, a positive number. Okay, so we can use this rule to get out of the absolute value inequality, get us into an inequality without absolute value symbols, which we already know how to solve. Okay, if you've forgotten how to work one like this, you can look at one of the earlier videotapes when we studied just inequalities, okay, without absolute values. Okay, the absolute value of z is less than or equal to a. This is equivalent to saying minus a is less than or equal to z is less than or equal to a. If all else fails and you can't reason this through logically, you can fall back on the formula. This is in the form the absolute value of something less than or equal to a positive number. So you put what's inside the absolute value sign in the middle here. This is the 2x minus 5. On the right-hand side, you put this number. On the left-hand side here, you put the negative of that number. Okay, now to solve this inequality, we would like to isolate x alone, okay, in the middle. Now we know we can add or subtract the same number to all parts of an inequality, no problem. We get an equivalent inequality. You can multiply or divide all parts of an inequality by the same positive number, also okay. But if you multiply or divide all parts of an inequality by a negative number, you have to reverse the directions of the inequality. Okay, so here we can add 5 to all parts without any difficulty. And we get 0 less than or equal to 2x less than or equal to 10. Then we would like to isolate the x alone in the middle, so we divide all parts by 2. It's a positive number, so we keep the same directions. 0 divided by 2, that is 0. Remember, it is okay to have 0 on top, not in the bottom. 0 divided by 2 is 0. 2 divided by 0 doesn't make any sense. Less than or equal to x, less than or equal to 5. Okay, that is the answer, the values of x which can be substituted in here and make this come out a true statement. Okay, are all those values from 0 up to and including 5. And we can indicate this on the number line as follows: 0, 1, 2, 3, 4, 5. And the negative numbers are here. We want from 0 up to and including 5, including the endpoints, so they're filled in. Okay, let's try another one like this. The absolute value of 9 minus 2x is less than 3. Okay, this is just less than, not less than or equal. Okay, it still comes under the less than category, and we have the absolute value of z less than a can be replaced by minus a is less than z is less than a. This is equivalent to the following inequality without absolute value symbols. The absolute value of z is less than a is positive. We can place the z value in the 9 minus 2x in the middle. This number here, it's negative over there. Okay, we'd like to isolate the x in the middle of the inequality. First, we will subtract 9 from all parts. Minus 3 minus 9, that's minus 12, less than minus 2x, less than 3 minus 9, that's minus 6. Okay, now we would like to divide all parts through by minus 2 to get x alone, but we're dividing by minus 2. You see, in this example, we divided by plus 2, a positive number, and therefore we kept the same directions. They were less than, and they stayed less than. Okay, here, however, we're dividing by a negative. So if we're going to divide by a negative, as we divide by a negative, we reverse the directions. A less than becomes a greater than. We divide by a negative. The less than becomes a greater than, and we divide by the negative. Okay, minus 12 over minus 2, that's plus 6, greater than minus 2x over minus 2, the minus 2's cancel, greater than x, greater than minus 6 over minus 2, that's plus 3. Okay, 6 is greater than x, and x is greater than 3. Now, this is sort of the opposite way we usually write it. 6 is greater than x means x is less than 6, and x is greater than 3. That is, x is stuck between 3 and 6. Okay, you might prefer to rewrite the inequality like this. Okay, I am not, some people say, well, are you multiplying by a negative? What gives you the right to reverse the direction? I am not reversing directions. This inequality is the same as this. It's like instead of saying 6 is bigger than 3, we turn around and we say, well, 3 is less than 6. Okay, we're just looking at it the other way. It's really the same inequality, just writing it in the opposite fashion. 6 is bigger than x, and x in turn is bigger than 3. That is, x is stuck between 6 and 3. We're writing here x is stuck between 3 and 6, which is a more natural way of looking at it. It also is more helpful if you want to sketch the picture. 0, 1, 2, 3, 4, 5, 6. All those values between 3 and 6, but not including the endpoints, because it's just less than, not less than or equal. From 3 to 6, but not including. Okay, now let's look at absolute value inequalities involving the greater than symbol. Let's look at our number line again. Okay, and let's look at the example. The absolute value of x is greater than 2. Okay, this means the distance between x and 0 is greater than 2. Or x is more than 2 units away from 0. X has to be more than 2 units away from 0. As we have a certain region around 0 from minus 2 to 2. Okay, x can't be in there, because if it was in here from minus 2 to 2, x would not be more than 2 units away from 0, then x would be less than 2 units away from 0. We want it to be more than 2 units away. So the answers, the solutions to this inequality, must lie in the extremes. Okay, that is to be greater than 2 or less than minus 2. Answers on either end of the number line will be acceptable. Okay, we know that, for example, a number like 1 is no good. The distance between 1 and 0 is not greater than 2. The distance between 1 and 0 is just 1. It's less than 2. But once you go over 2, for example, 3, 4, 5, in all those cases, the absolute value is greater than 2. That is, the distance from 0 is greater than 2. But you're also allowed to go in the other direction. Okay? While, for example, the number minus 3 is not greater than 2, minus 3 is less than 2. The absolute value of minus 3, that is, the distance between minus 3 and 0, is greater than 2. The absolute value of minus 3 is 3. That is greater than 2. The absolute value of minus 4 is 4. It's also greater than 2. So the answers to this inequality, the solutions to this inequality, lie on either extreme. That is, x can be greater than 2, or x can be less than minus 2. There is no way to combine this into one inequality. okay, you have to write greater than 2 or less than minus 2. It would be very wrong, okay, to write something like this. Oh, minus 2 is greater than x is greater than 2. Okay, well, some people say, well, wait a minute, this is x is greater than 2, and minus 2 is greater than x. Isn't minus 2 greater than x the same as x less than minus 2? That is true, except this means and. This means minus 2 is bigger than x, and x is bigger than 2. From that, this means minus 2 is bigger than 2. This doesn't make any sense. Okay? When you write an inequality continued in that fashion, there is an and implied. X is bigger than 3, and it is less than 6. Okay? At the same time, you've got a number which is both bigger than 3 and less than 6. That is between 3 and 6. Okay? Here, if you had written it this way, x has to be less than minus 2 and greater than 2 at the same time. There are no numbers that are less than minus 2 and greater than 2 at the same time. But you must write them separately. X greater than 2 or less than minus 2. Always remember that. Your answer to a less than inequality, okay, will be a continued inequality like this double kind of inequality. That's for the less than problems, because we're saying the distance between a number and 0 is less than something. In other words, you're staying in some sort of region around 0. Okay, here you're saying the distance between a number and 0 is more than something. Okay, we're excluding a region around 0. We're getting these two intervals that are not touching, okay, that are not connected in any way, and we have to write them separately, greater than 2 or less than minus 2. Okay, and we can extend this to get some rules. Once again, if a is a positive number, the absolute value of z is greater than a can be replaced by the following two inequalities without absolute values. Z is greater than a, or z is less than minus a. Okay, and similarly, if it was the absolute value of z greater than or equal to a, it's handled in the same fashion. The only difference is that the signs have the equal included. Z greater than or equal to a, or z less than or equal to minus a. The greater than inequalities are split to indicate that we're talking about the extremes of the number line. Greater than a or less than minus a. The less than inequalities are just continued, giving you a double inequality like that. Okay, just over here a word about this idea of a positive number. Let's see what would happen if we had a greater than inequality with a negative number. We looked at it over here when it was a less than inequality, the absolute value of x less than minus 4. We saw there was no solution. Okay, the absolute value of a number was always 0 or positive. It could never be negative. It certainly couldn't be less than a negative number. Now let's look at a greater than inequality involving a negative right-hand side. The absolute value of x, say, greater than minus 4. We want to find all values of x that you can substitute in here so that the absolute value of the number will be greater than minus 4. Well, what numbers work? The answer is all numbers work. For example, if you substitute in 1, the absolute value of 1 is 1. It's greater than minus 4. If you substitute in minus 10, the absolute value of minus 10 is 10. It's also greater than minus 4. All real numbers work because, as I mentioned before, the absolute value of a number is either 0 or positive. In either case, it's certainly going to be greater than a negative number. The absolute value is a distance, which is the smallest it's 0 is 0 or positive. It must, of necessity, be greater than a negative number, any negative number. Okay, so the answer to an absolute value inequality, a greater than with a negative right-hand side, is all real numbers, while the answer to an absolute value less than inequality with a negative right-hand side is no solution. Okay, let's try to work out some more complicated greater than inequalities. The absolute value of x plus 2 greater than 3. x plus 2 is some number, okay? The distance between x plus 2 and 0 is to be greater than 3. That is, either it's going to be bigger than 3, in other words, or larger, or small, bigger than 3 or less than minus 3. Okay, the distance is going to be greater than 3, so the number will either lie to the right of 3 or to the left of minus 3. Okay, and if you feel more comfortable with the formula, remember that this is the absolute value of z is greater than a, can be replaced by z greater than a or z less than minus a. Two inequalities without absolute values. Okay, the same way we solved an absolute value equation by replacing it by two equations without absolute values. Okay, we can replace it by two inequalities without absolute values. Z is x plus 2 in this case, greater than 3, or z x plus 2 is less than minus 3. And you cannot combine them. It must be two separate inequalities, and they're to be solved separately. X plus 2 is either greater than 3 or less than minus 3. It lies in the extremes on the number line. Okay, we subtract 2 from both sides here, and we get x is greater than 1, or we subtract 2 from both sides here, we get x is less than minus 5. Okay, the answer, if you wanted to sketch the graph here, 0, 1, 2, 3. We want those values greater than 1. Okay. Here are the values that are greater than 1 or less than minus 5. Okay, notice that the answer to this kind of inequality, when you graph it, okay, you get the two ends of the number line. X is greater than 1, strictly greater than 1. If it was greater than or equal, this would be filled in, or less than minus 5 on either end. You wouldn't be between minus 5 and 1. Those values would have the absolute value less than 3 when you substitute into the equation, the inequality up there. Okay, let's try one more of these. We're going to solve the inequality and sketch the graph. The absolute value of 3 minus x is greater than or equal to 1. Okay, this is the absolute value z greater than or equal to a. Replaced by z greater than or equal to a or z less than or equal to minus a. Okay. The distance is to be greater than or equal to 1. Okay, so the number 3 minus x is going to lie to the right of 1 or to the left of minus 1. Z is 3 minus x in this case, and a is 1. Okay, here subtracting 3 from both parts, we get minus x is greater than or equal to minus 2. And we would like to get x alone. This is minus x greater than or equal to minus 2. So we will divide both sides by minus 1. Remember, this is like minus 1x. We will divide all parts by minus 1. And in doing so, we change the greater than or equal. We make it a less than or equal. And here we divide by minus 1 as well. Here we get x less than or equal to, now minus 2 over minus 1 is plus 2. So we get x less than or equal to 2, or, and now let's solve the other one. Subtracting 3 from both parts, we get minus x less than or equal to minus 4. Once again, this is like minus 1x. We want to divide both sides by a negative. The less than or equal is reversed to a greater than or equal because we're dividing by a negative. And we get x greater than or equal to 4. X less than or equal to 2 or greater than or equal to 4. And we can sketch the graph over here. We want less than or equal to 2. Here is 2. Less than or equal to 2, and also or greater than or equal to 4. Either extreme. Anything that is 2 or smaller or 4 or bigger will be an acceptable solution to this problem. And that brings us to the end of the tape.